In this video, I'm going to look at a possible alternative to the ESP-r tester facility. For actually decades, the ESP-r development community has been using named tester.pl. It's a substantial edifice, lots of lines of code. It's very functional. However, it's expecting models that are relatively old. ESP's moved on a bunch from it, and the community has kind of forgotten around what goes on under the surface of the thing. Here's a brief review of the tester facility as it exists. There are a bunch of scripts, and the main one is tester.pl. If we look at its properties, we see, 164 kilobytes of code. It is driven from a command line with lots of options passed into it. Depending on what you want to do, you give a slightly different command line. So it's possible to automate things. And what it relies on is files in various folders, particularly the test suite. Different types of tests and different models are held in different folders. For example, this one looks at the Alberta infiltration model, and in that is a number of different configuration files. They each run a similar period and generate data from that. There are, however, other kinds of models, such as these benchmark models, where in the configuration folder you see both summer and winter variants for each of the things being tested, and this is an artifact of how tester is working and its view of what ESP-r used to be able to do, which in fact says that there's a simulation parameter set, but they go in and literally edit the file to force it to do different kinds of things, and that's a bit of a hassle. In the wintertime, there's also a thing called test, and with a period in there. It'd be nice not to have that many different models working on things. So, is there an alternative? Well, the project manager actually has a facility that manages BESTEST models, and I had a look at that to see what's going on. And there's a quote PIF file which Res will create and then allow it to replay a complex series of data extraction processes. It was missing some things, so I went in there and worked on it, and also looked at what the file format is, and basically I've updated that file format so that some things are following more in the line of what ESP model files look like, and also extends some of the data structures in there to hold additional information. So here's period, all held on a line rather than multiple lines, and here's the metrics, and it's giving some feedback in there about, number 5 is statistics and that kind of thing. So rather than just saying style, you've got a bit more of a flavor about what it is that is being held in that file. One of the things before is, we need to be able to do things like histograms. That needed a little bit of work. We certainly needed something or other for more information in order to do monthly reporting. We needed to add some attributes from Res into this file to make that work. Energy balances weren't included at all and have now been made available. So all these different things that standard extract shell scripts are running can now be basically encoded within the PIF file. And the file, to me, looks somewhat better than it did. if we're running save level 4, basically it's expecting to put out this kind of data statements, and indeed with the PIF file it's now possible to get exactly the same file as we did if you are running by way of a script, which is a useful kind of thing for alternative for people who don't actually like writing scripts to do data extraction. They can simply run res, collect up this information, and then they've got it without having to do that kind of coding. So that's a step forward. Next sort of thing is the list of the models and directives that's in BESTEST. There are a lot of irritants within that file particular format, and we need to do slightly different kind of test within a tester equivalent. So on the left is the BESTEST thing, and here on the right is an evolution of it in terms of what might work for tester. So for example, there's some things in here that show where the paths of the standard and the test version of ESP-r, where models are going to be living, and where to put the report information in there. And then we've got then for the configuration, the information for each of the models that we want to run. So what's the configuration file? What's the path to it from that root location of the models? And then the name of the configuration file, not with the path, and that seems a whole lot simpler than what we had, and some sort of a title so that we can select things. And then we're passing into it the name of the simulation parameter set in a slightly different way. Here it's just the name of the simulation parameter set that's being used, that's available within the configuration file. And then we have this PIF file. What's the name of that? So that res has a directive to run with, and then set it up to where everything that res generates as results.bres, and then there's two sets of things for the standard report and for the testing report, where there's data files and summary files being run when we've got a save level 4. And then here's for the test version of ESP-r. What are the names of those? And then we've got a special case for save level 5, where res isn't run at all. BPS does all the heavy lifting, and therefore we've got some summary files, and we've also got this thing called an H3K file, which summarizes lots of things. So that brings us in line with what tester is doing to generate those kinds of things. Okay, let's look at the files and the folders in what I'm currently working on here. I put stuff in a thing called alt tester, and in there are some model folders which are pretty much laid out the same way as they are. The file names are all the same, however it's newer files, and in them we've got basically the simulation parameter sets. So a save level 4 for test and a save level 5 for test with the periods and all of that. So there is no need for any editing of that file in the process. And then here's the performance information file, which was generated by running res with the extract script, but with turning on the recording information, and it then generates this file. And if you run res in recovery mode, it generates essentially the same thing that it would have done if you ran the script. So we can move on and use the PIF files rather than invoking an external script. Just a reminder, here's what those typical shell scripts look like. Whole series of commands in there. It's relatively straightforward to do, but somewhat rather tedious if you're trying to create these things from scratch. If we toggle on the PIF facility in res, then we can issue the same command and we'll get our PIF file. If we've got a kind of test that is only running one particular season, then that's no problem. If we got multiple seasons, what we have to do is transition these files from one that's got summer and winter versions of the thing to a single version that's got the information for both of those periods. And this is just going to show you a brief transition of an earlier model to a newer one. We're taking away the summer from the configuration file and also from the connections file. And once we have that, we open it up in Proj and we do a save as. This is to update the model configuration to the most recent version of things, and also to check that the file names are consistent. And so we're going to take this word summer away from the base name for the project, as well as from the connections file. And then we're going to save that to the latest file format. And essentially that's done. Now, what we want to do is regularize the simulation parameter sets. To do that, we're going to use meld with one that we've already set up versus this one which we've just been creating, and copy over the simulation parameter sets. So essentially, lots of things are the same. There's small differences here, there, and yonder, but the only thing we really want to change is to pull across these standard names and periods for the simulation parameter sets. Save those changes, and then we're ready to move on to the next step. So this master list for the tester equivalent, at the moment I've just called it self-test list. And in there, we have various things like where the paths to the standard and the test version of ESP-r, where it's supposed to go and look for the models. Why put that particular path in every particular thing? And also there's a directive about where to put the test reports. At the moment, I've picked that. We might decide to change it. And so here's a typical item which says basic AIM maximum. There's a configuration file, the root name, the simulation parameter set name, the PIF name, and all those sorts of things. And then the names of the files that it's going to be generating when it runs. Again, there's some attributes for the standard version of ESP-r, and a set of attributes for the test version of ESP-r. Now, those file names are the same. They're actually being put in different folders with the same name, so it's easy to compare the two. Of course, if you've got an XML, input.xml file, you will always get a summary file that BPS generates. And then here's for a save level 5 variant. Yes, so in the PIF file is simply named SL5, and that signals to it not to bother running res. But then we've also got an extra thing in here for a standard version of H3K file and for the test version of things. And we carry on doing that for the various models that are set up in the folders. And yeah, there are lots and lots of them. And then here's another set for the base simp models. And we've got others for the test variants and that sort of stuff. If we look at the standard reports, in this particular case, I tried compiling with a different compiler, and all the results, there are no differences in there. So that was a quick check to see that a newer compiler is not doing that. But what if I compare with last year's version of the ESP-r? Well, here's one I did there. Oh, goodness, lots of blue things in here. How bad is that? Well, okay, so we're 3 hours different on the peak timing of things. And that's the only difference in that particular file. Here in the summary file, okay, we're changing things at the second and third decimal level, maybe the fifth decimal point, and therefore, yeah, it's not identical, but what we need is a tolerance check going on there. Tester Perl script does it. We need to be able to do that ourselves, and in fact, that has been enabled within the project manager to be able to do those kinds of things. And then what we've got at the end of the thing is that we've said, hey, I'm going to put this stuff in a report and summarize all the things that were different. So some lines are simply, it's a text data file, and there are some character differences in there. And in other particular cases, we're looking at a summary file, and then we've checked for tolerance. And in fact, in that particular case, the summary file is within tolerance, and we work through on there. So this is somewhat equivalent to what was being done in the tester. We have the ability to find out what's different. Of course, with just a text file, yeah, something at the third decimal place, yeah, it's not an identical file. So what's it like to run this thing? So we invoke Project Manager in text mode. And there is a new option here. Well, we go into the self-testing facility, which has existed in the past, but we've got a new thing in here called self-test. And if I pick that, I'm asked to provide the name of this master list of things to be done. And here are the different groups of tests that we could be running. We can pick all of them, or we can pick a subset of them. For example, if we just check the basic and detailed AIM, then we're shown all the variants in there. And if we say select all, fine, then it will proceed on that basis. And then I want to nominate, where do I want to put stuff, the results of all of this testing. And so I'll say aim comparison. And then it goes off and invokes both versions of the BPS and of res, and it does the comparisons and the tolerance checks, cleans up after itself, and carries on writing information as it goes to that report file that we asked for. And you can see that here's various files that are being written into these folders holding the test and standard versions. And at the end of the process, we can exit. And let's see what was in that comparison report. And basically, the DAT files are identical. The summary files are within tolerance. Again, this is the stuff behind that test of, does the compiler make any difference through there? So it's work in progress here. I've done some of the folders from tester and converted them, but there are more to be done. There's a few facilities that still need working on. BPS really should convert all ASCII shading files to binary ones if it doesn't find the right ones in place. But basic question here, shall we continue in this direction? Is this a useful way of going?